There are many reasons that a particular reaction might produce lower than the expected mass of a particular product. So for instance, there might be unwanted side reactions, or there might be an incomplete reaction between the reactants, or some of the product perhaps is lost, perhaps on transfer, when separating, e.g. filtering, and so on. So we use percentage yield as a measure of how much of a substance in grams. So the mass in grams of a substance is actually obtained in comparison with the maximum possible mass. Percentage yield, therefore, can be defined as follows. So percentage yield equals the actual mass obtained divided through by the theoretical maximum mass, and then to turn that fraction into a percentage multiplied by 100. Let's do an example to illustrate this. In this example, quicklime calcium oxide can be made by thermal decomposition of limestone, and there's an equation there. The question says calculate the maximum theoretical mass of calcium oxide that can be made by heating 50 grams of calcium carbonate. So just as with any other reacting mass calculation, start off with the balanced equation. So CaCO3 produces CaO. Oops. Let's just delete that. Try that again. CaCO3 produces CaO and CO2, and the mole ratio for that is therefore 1 to 1 to 1. So the moles of calcium carbonate the same as the moles of calcium oxide, for instance. The mass that we've been given here is 50 grams of calcium carbonate. We need to calculate the mass of calcium oxide, not interested on this occasion in the CO2. So to convert the mass to the moles, we need to calculate the MR. For calcium carbonate, that happens to be 100. For calcium oxide, that's 56. So the moles in question is the mass in grams divided through by the MR. For calcium carbonate, 50 over 100 is 0.50 moles. We know that this is a 1 to 1 mole ratio. So the moles of calcium carbonate in theory is the same as the moles of calcium oxide, so 0.50 moles of calcium oxide produced. So the mass, or the maximum mass of CaO, is equal to 0.50 times by the 56, and that should give 28 grams. So that's a theoretical maximum mass of calcium oxide that could be produced by heating 50 grams of calcium carbonate. In the next part then, in the reaction, only 26 grams of quicklime was actually produced. Calculate the percentage yield. So this is fairly straightforward now. Percentage yield equals the 26 grams actually obtained divided by the 28 grams theoretical maximum mass. Multiply that lot up by 100. I'll just edit that text, which has gone strange again. Let's just get that back. 26 over 28 times by 100. Put that into the calculator, and that comes out at 92.86%, which is 93% to 2 sig figs. And I've chosen 2 sig figs because the rest of the data was given into 2 significant figures. So percentage yield is really a measure of how effective that particular technique is, how much of this substance has been lost through doing this experiment. And percentage yield calculations are just an extension then of the reacting mass calculations that you have met earlier this week.